All right, welcome back. You've now finished the DocuCenter, which was module 2.1. And now we're going to look at the next section. So you've done module 1, introduction, why steel, and then 2.1, the DocuCenter. 2.2 is fenestration types, norms, and furniture. And just to give you some background, in order to communicate with architects and with metal workers, it is best to have shared language. So what the Europeans have done over many decades, in fact around the world, what the world has done through ISO standards and other norms and codes, they've developed norms and ways of illustrating, whether it's icons or typology or symbols, which indicate what you're looking at when you look at a drawing. So you'll see on some of the window and door drawings, there's little annotations that are either hatched or they're in a triangular shape, and that indicates where the doors open: inward opening left, or inward opening right, or outward opening left, and so on. And there's still in the South African market a lot of confusion with what is a left-hand door and what is a right-hand door. And if I ask you the question, what's a left-hand door? How do you know what a left-hand door is? And I've asked that many times, and I get different answers. So they go through some of those, the typical types of facades, the doors, windows, and they give you an indication of what these elements are called. It makes up a window, what is a mullion, what is a transom, and so on. And then looks at some of the European norms, and then the furniture and how the furniture works with the systems, with the profiles. So those are various types of locks, panic locks, thumb turns, and keyed latches, and so on. So that's what's up for module 2.2. When you come back, you'll be doing safety systems, fire, security, and bullet resistance. But for now, it's fenestration types, norms, and furniture. So enjoy.
Okay.
We'll
So
try
this
closer.
Okay. All right. So this presentation shows the let's say the basics of all windows, doors, and facade systems. The components and elements, how do we, what do we call them? And just to have the same terminology. Facades. Facades are fixed elements without any opening or moving sections. So transoms and mullions. This is it. Doors have are either two wing doors or one wing doors, double wing doors. Of course, their function is to open and close correctly. Windows are elements either built into the building substance, so directly to the wall, or connected to a fixed section or even a facade. So that's pretty clear.
Yep.
The outer door frame is the frame that connects the whole structure to the wall, to the building to the substance of the building. The outer door frame. It is also, we also talk about the outer frame when we talk about facades or fixed elements. This is the outer, the perimeter frame of the element. The leaf frame is the inner frame of the moving element. Sorry, just jumped. Okay. Leaf frame or window frame is the inside, the frame of the moving element. Yeah. So when we talk about this is the part where the fittings are. So the inside of the fittings, and of course always the inner and outer frame have to match. They have to. They are responsible for the closing and opening function of the door and the window. Okay. So we have that. The door sill. This is the lower profile on a door. Oftentimes it is a bit wider than the rest of the profiles, so the leaf frame. The reason is manifold. It's the protection of the lower part of the door, protection from the weather, just humidity, rain, and so on, but also protection from mechanical impacts such as kicking the door in a school or opening the door with your foot, slamming the door. The forces are greater here in this lower section than in the rest of the door. Therefore, the door sill is oftentimes wider.
Do you offer on those thresholds incorporated into the system? Do you do sort of like acoustic barriers or bacterial barriers or those retrofitted components?
Yes, there is different types of let's say floor details.
Yeah.
Sorry, I guess, okay, I'm showing you the wrong, hold on, actually, I'm showing you the wrong one. Yes, I will answer your question immediately. There we go. It looks better. Yes, we have different bottom details or threshold details from barrier-less or just flush sills. We have striking sills inside outside. We also work with drop-down ceilings when it comes to acoustic protection or, for example, smoke protection. That's where our drop-down ceilings come into play. You can either use one or two on many profiles. So these are the possibilities we have. There are manifold.
Yeah.
There are manifold.
I think the ones that have been the ones that I'm experienced with, the ones that get emphasized the most is thresholds that give improve or reduce air leakage and acoustics. Those are the, I feel like, two big ones.
So this will be the striking threshold and the drop-down ceiling. Striking is the or the flanged striking profile is the one, especially when you have the flange on the inside, on the outside, and the pressure comes from the outside. That's the best or the most, let's say, what do you say, the most perfect sealing, the flange on the outside, the gasket on the outside, and a striking profile. That's how you achieve the highest
performance.
Exactly, the air and rain performances. Acoustics is usually the drop-down ceilings.
Yeah. Okay.
Okay.
I'll look through the catalog.
Please, and here especially you will find the information in the processing and assembly brochures. That's where these threshold details will be described and how you assemble them. Okay. Mullions are the vertical profiles on a fixed structure or therefore also a facade, or the ones attached to the window, for example. And the transoms are the horizontal profiles. So in facade, we talk about transom and mullion facades, and these elements are also used for the fixed elements. Here you go, door leaf mullion. Well, I guess that's the right term in English. I couldn't find it really what you call these things. Oftentimes these mullions are not for stability reasons or for statical reasons, but rather for decoration, where you just divide the door into sections, or when you do restoration and you want to keep the old window in the same, let's say, appearance with the segmented small windows, you use these door leaf mullions or transoms, I guess. So these are, as I said, not statical elements, but just decorative elements.
Yeah.
Or ornamental mullions called, yeah.
Mullion is fine.
Yeah,
that is
mullion is fine. The transoms, same thing applies here.
Yeah.
We see less and less of them. In renovation, you'll find them more.
Yeah.
They actually decrease the thermal values of the element. So yeah, they I don't like them personally, but okay, they're there. Glazing beads. Glazing beads are let's say thinner profiles. They're still tubes or half tubes, open tubes that we use to keep the glass in place. When you put the glass in the frame, of course you have to make sure that it stays in place. And here you use the glazing beads. We have different materials for the glazing beads, different shapes, from the standard rectangular ones to design to very slim glazing beads that just change the appearance of the window. So depending on the system, you may want to choose from either the aluminum section or the steel section. So possibilities are many, and I will talk more about the glazing later on. Yeah, fixation of glasses, fixed glazing. These are the glasses that cannot be opened, as you see here, either on the facade or a fixed section. non-moving or opening elements. The emitter joints are the joints where you where you first cut the profile at a 40-degree angle, and then you weld it, you grind it. In the end, you have a uniform surface. Emitter joints. T-joints are the joints, just like the word says. Well, the T connection here on a facade. Here we don't have a 45-degree angle. We just have a 90-degree angle. And you do see the connection. So on facades and on these mullions, on these decorative mullions, that's the way you connect them. So the T joint. Cross joints are, as the word says, connection of two joints in a cross way or a crossing manner, two profiles. And a dull joint is what you will find either on the facade or also on the glazing beads. This is how we connect the glazing beads. They're actually not connected, but this is what you see. So you will see the gap on the joint. Yeah, that's how it's done. Otherwise, you will not be able to actually position or insert the glazing beads. So that's the way to go.
Yeah.
Mm-hmm. Often glazing beads. Yeah. So this is it. So this is the couple of words, a couple of terms, so technical terms that you should know when we talk about windows. We use them, so we know what's the matter here. What we talk about. Let's talk about the opening directions of windows and doors. Important when you talk to the architect, to the metal worker. The opening type of a window will sometimes be decisive in choosing the system. Our systems offer a lot of, let's say, exotic opening types, swing doors, swing windows, pivot doors, pivot windows. These are the types of opening that other systems oftentimes don't offer, and this is where you're automatically in the game. But let's just go step by step through this. The opening directions and types are defined in a European norm, so this is not something that we invented. We are just following the norm. First of all, the opening direction. Well, when you pull the door towards yourself, you will already see in which direction the door opens. Opens to the left. Then we speak about the opening direction left. And in fact, following the European norms here in Europe, we speak about opening direction DIN left. So DIN is the German industry norm, an abbreviation. We use this word. For you guys, I think it's enough if you just speak about an opening direction left. What gives you the hints which way the door opens? Well, it's the hinges. When you see them, then it's kind of clear. You pull it towards yourself. The light switch is also an indicator to which side the door will be pulled, and therefore to which side it will open. So this would be exactly, this is the description here. The switch is usually located on the handle side if you only have one handle.
Yeah.
So here again, if you open to the right, then it's the right. Here again, I mean, it's kind of self-explanatory. The direction you pull the door towards, this will determine your opening direction. If you have concealed hinges, then again, it's the pulling action to whatever side the door opens. When you pull it, that will determine your opening direction. So pretty clear here, explained from different angles. It will become a little more complex or complicated when we have double wing doors, which also are panic doors. Here you see a good example of this, panic handles. First of all, you don't know which one is the first opening leaf, which one is the second or the secondary leaf, and you don't know the opening direction. Okay, here the push bar will indicate it, but more important, if you want to determine that, you will have to look at the cross section. In this case, of course, the first opening leaf will be on the right hand side, which is usually the rule, usually the case. The shape or the geometry of the profile will determine it. I mean, you see here the flange. This will be on the outside, so the only way to open is this way. Therefore, it will be a left opening first leaf. Again, here we have it. What also helps you to determine which is the first and the second, or the first opening or the secondary leaf, is the position of the handle. The horizontal position of the handle indicates, okay, I am the first leaf, the first opening leaf, and the vertical one is the secondary leaf. This is how it's often handled here in Europe. Sometimes the handle is even repositioned. Okay, of course, the escape sign helps to recognize the opening direction, and again, the right leaf is usually the first opening one. If this is not an indication enough, then you will always have the possibility to position the vertical handle, let's say some 30-40 centimeters up higher, and again, this is an indication for the user, don't use me first, use the right leaf first.
Yeah.
When you have a full panic door with two push bars or push handles on both leaves, then it may be a little more complex to recognize the first opening leaf, but here the indication will be the cylinder. So the lock is an indication. It's well, it's on the first opening leaf. So here it's clear. When you don't have a lock, you will have to look at the width of the profile on the door leaf. The thinner profile will be the first opening leaf. The reason being, you see that here, the thinner profile will be the one on the inside. The flange is on the outside, so the flanged side will be on the outside where you push open the door. So here the thinner profile will be the first opening, the wider one, the secondary leaf.
Yeah.
Okay. Good. Then again, here it would be a little test, the door opening direction. Now you have to just change your perspective a little bit and pull the door towards yourself. So this will be a single leaf left opening. This will be a right opening door. This will be a left direction again. So it always depends on your perspective, on your standing point. The windows. Windows offer more possibilities of opening types. First of all, the indication, when you see the drawing of a window, you will see a line here. The line can be either a continuous line or a dotted line. Continuous line means the door opens inwards, so towards yourself, if you're standing on the inside of the building. A dotted line would mean the door opens to the outside. Yeah, so it opens outwards. That is the perspective of the metal worker and also of the planner. Yeah, this is how he sees the window. I will show you later an example of how an architect sees a window. He sees it exactly the opposite way. So he will exchange the views. An architect sees the window or a door from the perspective of the outside of the building. Yeah, so that's an important thing to keep in mind. All the catalogs, all the drawings in the catalogs that we have in the Janssen world have the perspective of the metal worker. Yeah, so what I'm showing you is from the catalogs. So the line's clear? I guess clear.
Yep, makes sense.
Okay. That's it. That's again, yeah, metal workers and planners use the view from the inside, architects from the outside. So this is exactly reciprocal. Okay, okay, this is the explanation of the lines again. A solid line means the door opens to the inside, towards yourself. If it's a dotted line, it opens towards the outside. And the architect's view, exactly the opposite. So again, this is a confirmation to what I just said. Now, types of windows and doors, and these types you will find all of them in the Janssen let's say, portfolio or possibilities of portfolio of possibilities. The most common is the turn window that we use here in Europe. Turn window, outwards opening. We have dotted lines, clear. Direction right. When you pull down window, it opens to the right. Next window is inwards opening. It has a solid line. and direction is left, opening direction. Again, here you're standing on the inside of the building, pull the door. On the first example, you would have to be standing, so to speak, on the outside of the building, and then you will have the direction right. Here it's left. This window features two types of opening combined. One is the turn, and this triangle pointing upwards is the tilt function. So combined, we call it the turn tilt window. And since we have the solid lines, it's opening to the inside, so inwards opening. And direction is right. Okay, so turn tilt, actually the most popular window in Europe. Fixed glazing, we talked about this, no opening possibilities. Facade section, facade element, or just a fixed window. Tilt window only, inwards opening. This is what you see here. Oftentimes these are the skylight or the top lights on top of a facade element or a fixed element, oftentimes just for ventilation purposes. Same thing here, opening to the outside. Careful when you have the exposure to the wind and weather. The outward opening windows may actually lead to some flooding on some occasions. So make sure you choose the right type of opening when you work on a project.
Or make it top hung.
Excuse me?
Or make it a top hung, as you said.
Or made it a top hung, which we have exactly. This is the page that we have here. Top hung outwards opening, top hung inwards opening, a vertical sliding window, typical US for the US market or Great Britain. They use a lot of these. We use less of these actually here in Central Europe. Then we will have again a projected top hung window, outwards opening, dotted line, a projected top hung window, inwards opening, and then the next one is a swing or a pivot window, outwards opening. Yeah, so the lower part of the window opens outwards. What else do we have? We have a swing window. So here you have the bearings not on the side, but on the top and on the bottom. Yeah, so it's similar to the pivot or the previous one I just showed you. The swing window and the swing window here horizontal. This is what it's done. How it's done. An interesting, let's see, opening type, quite popular, especially with Arte 2.0, Arte 66. This is what the customers go for. Horizontal sliding window. We have several systems here on Janisol and Arte and Economy. So just a slider. The gasket here is a brush gasket in the bottom. The only downside of this type of window is quite low performance when it comes to wind load and air permeability. One more type of opening as the PSK, the parallel slide and tilt window. This is, I don't know if you guys have this in your market. I see it's disappearing as a opening method. But still available. I guess we don't have these types of windows anymore We don't have them in the Janssen portfolio, but you'll find them in the market. These are rather the less expensive ones, and this state of the art or the market. Let's say the market standard are the lift sliding windows, where you have a lifting mechanism and then you slide the whole thing on rolls. This is actually what is built today. Terrace doors. Huge elements. We can build them either on Janisol or Janisol HI. And we can reach huge elements here, 4.7 by 3.2 meters. These are the sizes, 600 kilos per wing. So we can reach or achieve quite a lot with this type of opening wind.
Yeah.
All right. So couple of opening types. We went pretty fast through this. Again, this is more a what would you call it? A reference document than something you would learn immediately. It will take some time, but it explains what we talk about when we talk about these different types of openings. Locks will be okay, admittingly, it is a complex area due to the fact that we have a lot of functions and a lot of requirements, especially on the fire stop doors. I will just show you a couple of examples here how a lock or what kind of lock can be built into a door. When you have a single leaf door, we actually make a cut. We make a distinction between doors up to 2.50 meters and above 2.50 meters. We equip it with a different locks and different locking systems. Up to 2.50 meters, you can use just a single latch lock. This is good enough for most doors. When you have a door between 2.5 and 3 meters, you should or you must use a additional locking point. We always recommend a locking point towards the top. The reason is this locking bar that you see here on the upper part is screwed onto the lock. With vibration, this screwing may actually loosen when it's pointing downwards. And if it does so, it may actually block the door. It may get stuck in the floor. To prevent that, we recommend use a locking point towards the top. You don't have this risk of blocking the door. So here,
Makes sense.
single latch lock with additional locking point, 2.5 meters and above, single leaf and double leaf. On fire stop doors, always from 2.50 meters. You can also exchange or replace the additional locking point, the mechanical additional locking, by a so-called bimetal latch. This is what it's called. It's a piece of metal that expands quite significantly. So I don't know, it's kind of an alloy that reacts very strongly to temperature changes. This is actually for fire stop doors. When the fire hits the door, temperature rises, and this element expands and locks the door. I will show you the function of this element later on. It has the same function as the additional locking point, except it will get activated after a while, after the temperature reaches some 250 degrees. That's where it gets activated. But it will fulfill the function of a fire stop door, which is, in most cases, if it's not a panic door, it just has to close tightly and keep the smoke and fire away. And this is what this element does. Why do I mention this bimetal latch? The reason is it's very cheap. It costs some $7 here in Switzerland. It's and it is much more, let's say, much less expensive than the $150 additional locking point. So if this is allowed, if this solution is allowed in your market, it's an interesting solution for fire stop doors where you need an additional locking point to the top.
Cool.
Okay, so some possibilities here. There is, of course, many more, and I'll just want to give you a short overview of what you will find in the catalogs. All the locks that you will find in the Janssen catalogs will be described in a similar way. You will mostly find a normal function or standard function. This is the just the opening and closing function. Besides that, most of our locks also cover the emergency or the panic function B. Panic function B means you have handles on both sides. You have a divided splint, you call it. I don't know what it's called. This element. It's in the lock.
Yeah.
It's divided. The function B or the emergency function B allows you to leave the building in case of fire or emergency, but it will not allow you to enter the building again. So you cannot re-enter the building. The logic here is when it burns, there is no reason for the user to re-enter the building. So this is actually the main or the function used mostly in panic doors, function B here in Europe.
The fireman, he just breaks it down with an axe.
Right. There is, however, a function D, also called the firefighter function. It allows the re-entering of the building, so it will not disengage the outer handle. It will keep it engaged.
Okay.
The function, okay, and here we have actually also a video. I will send you the video which describes the functioning of the lock in this case. So just briefly, this is in German, but I'm sure you will find on YouTube also the video in English. Now this is the standard function. You can open and close the door. Yeah, this is always active. When you lock the door, the handle is locked, and the lock is still unengaged, but you can open the door, and then you basically just lock it. Now it's locked. Now this is on the outside. On the inside, the handle is always active, even if you lock the door. So it overrides the lock. The handle overrides the lock and allows you the escaping from the building. Yeah. So if you lock the door, it's always locked on the outside. You can get in. From the inside, you can always escape. You can always open it. The handle will override the locking function. So this would be B. And you have handles on both sides. Function E features one handle on the inside, so on the, let's say, escape side, on the inside of the building, and features a knob or nothing on the outside. So this function is really just meant to escape and nothing else, and never get in. So don't. It's like a back door, for example, or a delivery door, which you do not want to be used as a entrance door. But again, it can be an emergency door, and in this case, we talk about, or we speak about, a function E. And then again here, the video that's showing that function. And you see the knob on the outside when we lock the door. The normal function means you can get in, even if it's unlocked. And the knob doesn't do anything, but you can lock it from the outside. That. Now what happens on the inside? Same situation as on the function B. The handle overrides the lock. You can always escape. But once the door closes, that's it. Okay?
Got it.
All right. So this is it. This is E, and an opening just with the key. So without the key, you cannot get in through this door. Now, opening direction of a panic door or emergency door is usually towards the escape direction. So you're running out of the building, the door opens to the outside. Yeah, that's usually the rule. There is some occasions or some situations where the door cannot open to the outside. Imagine you are on a floor and the floor is connected, or the floor building floor is connected to a stairway. The stairway is quite narrow, and the stairway also serves as an escape route for the people from, let's say, from the upper floors, upper section of the building. And if you were to open the door towards the staircase, you would block the escape route. In those cases, sometimes the door will open towards you. You have to pull it.
Yeah.
Mm-hmm. Those cases are special cases. They also need to be. They always need to be discussed with. Here in Switzerland, it's the fire department. They approve this type of opening. It's an exception usually. Yeah, panic doors or panic/fire doors open usually in the escape direction. Now, let's just have a look at doors that are panic or partial panic doors. And there again, we have I don't know how you guys handle it in South Africa. Here in Europe, we speak about either a partial panic door or a full panic door. Partial panic door would mean the first leaf, the first opening leaf is equipped with the panic function. So it will feature a lock with the emergency function B or E. And the secondary leaf is not supposed to be open. So it's locked towards the top usually, and it's not considered to be an escape route. This would be a partial panic. Full panic means you can use both leaves as the panic or as the escape route, either left or right. They both have to open. Even if you press the handlebar or the handle on the secondary leaf, it will still open. It will push the primary leaf open first and then open. So there is no, let's say, no possibility of blocking the door. It will always open. Full panic function. The full panic function doors are usually installed in public buildings where the users do not know the escape route. They do not know how to get out. And all they want is just to get out of the building by pushing on the door. Well, even in the case where there is no light, the electricity is off, you have smoke everywhere. So for that case, you will use this type of full panic door with handlebars. If you have a building like an office building where the users know the way out, they have been instructed on the first day of the work. How to get out, where is the meeting point and outside of the building. This type of building will be oftentimes equipped with partial panic, and the panic doors will have a handle instead of a push bar. Less people, or let's say less traffic, the users know the way out, so here you can save some money. These partial panic doors and handles instead of push bars are less expensive than the example you see here on the right. Okay. Yeah, following still. Okay, thank you, because this is actually a lot of information, but I'm trying to get through this. Now, how do you lock the secondary leaf? Well, if it's a secondary leaf that is not used, not equipped with a handle, you can use this type of, I guess it's called a spanolette in English. It's an element that sits in the secondary leaf and is responsible for locking the door towards the top. It's spring-loaded, so when the door is opened, and if it's equipped with a door closer, it will close nicely, and it can be used as a fire door.
Okay.
Okay. If you have a double leaf door with the full panic function, so meaning both leaves have to open, both leaves of the door have to open. You have to have, and if you activate the secondary leaf and the door is locked, you have to have some device that will unlock the primary leaf. And for that, we use the so-called panic counter box. And this is a type of a counter lock. If you activate the handle on the secondary leaf, there is a metal plate that comes out and pushes the latch on the primary leaf and unlocks the door. Okay?
That's actually pretty smart.
Yeah, it's a standard. It's a standard element on all dual leaf doors or double leaf doors. Otherwise, you will not be able to activate the primary leaf. The secondary leaf, and it has to be. So, this is an element that you need to take into consideration, build it in. It can only be an electric element.
I'm more familiar with panic bar technology than with panic latch handle technology.
Okay, so, okay. Well, then you know the more complex side of locks. Locks for high doors, so between 2.5 and 3 meters. They always have to have a locking point towards the top. Again, here, if it's a secondary leaf and a fire door, you can use the bimetal latch. Otherwise, you have to use the mechanical additional locking point, which depends on the regulation in the country. Some countries allow these bimetal latches, some don't.
Yeah.
And for that, you will then go to the section where you have the locks with the additional locking point, so the extension possibility. You will also have to find the rod to it and the additional latch on the top and the reception part, the female part that sits in the door frame. So this is how you would build these type of doors. And here in the catalog, you will have the maximum opening height always, and the type of lock and the elements with all the item numbers. So you will see, according to, let's say following each type of the doors, which items you have to use to equip the door with the right fitting.
Yep, that's cool.
Mm-hmm. Then the locks again, we will have all the functions. So there will be the normal function and then the additional function listed So there again, sorry for the German section here. Somebody just pasted it. But all this is also available in English in the catalogs. We have a trilingual catalogs for all systems. One more thing I would like to just to mention at this stage. I don't know if you guys have the same regulations in South Africa. This is how Europe regulates it. And again, public buildings versus semi-public buildings, where the users know the way out, the escape route, are regulated by or described by two different norms. The norm EN 179 will define all the elements, all the requirements of a fire or escape door in a semi-public building. And here you see there is a handle. You can use handles on these doors. When you are in a totally public building, like a shopping center, a movie theater with a lot of traffic, a lot of high number of users, then you will you have to follow the European norm 1125, and here you always have to have the push bars. The doors have to have a other requirements. They have to open always. They have to be marked and lit and so on. So the lower norm 1125 has more requirements. It's the stricter norm, and again it applies to the public buildings where the users don't know the way out. So this is.
Yeah, I think maybe in residential we would follow the prior one, but I think more often we use the panic bar routes, the 1125.
Yeah. In residential buildings, as far as I understand, this will also depend on the size of the building and the number of users. So in some occasions, the residential don't even feature these. Well, no, wait, there is no. I'm wrong. There is always an escape door, even in residential. Yeah. Okay, sorry. I correct this. Okay, but yeah, oftentimes this is subject to the local regulations. What is the function of the door and what fittings you have to use? Well, look, you know better than I probably.
Okay. Just a few things. You're giving me a good refresher here.
Okay. Good. Okay, I can again hardly hear you guys. Would it be possible?
Sorry, I brought the speaker close as we can, and I'm projecting.
Better now. It already something changed. It's good now.
Okay.
All right. On most of the locks, most of them, I'm talking about maybe 80%. You can change the opening direction of the lock, so you don't have to select the lock to the left or right opening. This little movie shows you how to do it. There is actually two screws, one Allen screw, headless screw that you need to unwind and then change the direction, switch the latch, turn it around, and fix it again. So with basically 3 screws, you can change the direction of the lock. And this is a feature we have on, as I said, most of the locks. The older ones still don't have it, but the majority of the locks will. So now you see, you just change the spindle, I guess, is what is responsible for changing the direction.
Yeah.
The square spindle that sits inside. So this is it, and then again he will just change or flip the latch, and this will be it. So good to know. You will have it also in the catalog. This is also shown in the catalog.